Hey everybody, we're Dream Innovation. To begin off, obviously we're doing a ball shooter project. Found this little comic online I thought was interesting because when we first started out, all of our balls kept going straight up instead of outward. So if you can't see it down there, it just says, wow, I didn't even see where that one went. So from that end over, we've got Daniel down at the end, Ricky, Ian, Amir, and myself. My name's Matt. So the initial plans, if Ricky, you want to go ahead and take this?
The initial plans were going to be like a total trebuchet. And with most trebuchets, they're all on wheels. Well, most of them are on wheels to lessen the blow of the weight going back and forth on a trebuchet. So that, well, that's actually not a very good picture, but I had originally made a base on wheels. So when we made a trebuchet, the weight going back and forth would be let onto the wheels and not really to the ground and shaking the entire robot all over the place.
Are we able to turn off that light right up?
Oh yeah, is the second one too?
You do one. This one. You do one.
Maybe you guys can see it a little bit better.
Yeah, that was our original idea, and then we noticed that a trebuchet was not a good idea.
And then we also came up with an idea in regards to some way to kind of force these guys through.
Yeah, so we try to make two spinning wheels to kind of push the ball outward, and that wouldn't really work because we wouldn't have strong enough gears or motors to really push it out, even the requirement, and we're in a competition to kind of go as far as we can, so this wouldn't even probably make the requirements to even go 5 feet.
So, taking a look at the two ideas we had, we kind of decided scratch both of them and start fresh. So we went through quite a few different stepping stones in the process. I believe, Ian, did you work on the...
Yeah, so one of our original ideas was to use the mini red solo cups that are in the kits as the cup. That didn't really work out too well because the ball wouldn't sit far enough in them and it wouldn't have good enough grasp on it, as well as we were having difficulty securing it to the actual arm. So we moved on to something more like this, which, as you can see, we braced using the NXT pieces onto the Tetrix, like right here, attaching it to the arm. That didn't really work out too well because it couldn't stand up to the force that was being exerted on it from the arm moving. So it basically flew to pieces.
Here's a better picture so you can see exactly what he was talking about. Up top you've got the NXT and brick that's held into the Tetrix piece with just some blue connectors, and pretty much, as you can guess, as soon as that came to a stop, that little gray piece went flying as well as the hand. So we took the ideas that we had and we went and improved on them. For the hand, we took two of the Tetrix pieces. One of them is a cross joint here. So we put one of the longest NXT Legos that we had and just continued to brace it up. That's probably one of the strongest points on the entire project actually, because that's pretty much the only thing we haven't had to redo or repair after repetitive launches. And then, was it, who worked on the motor?
It was pretty much, well, I worked on the mounting part of the motor, so I'll talk about it. This idea actually was another thing that went and carried out throughout the entire build. What I did is I just put on the back of the frame, I put a vertical Tetrix piece, and then I put two keyed axles through it with one of those plastic bits holding a geared spool together. And what this does is it takes the arm all the way back down to its loading position.
And once the arm is in the loaded position, we needed some way to keep it there while the motor unwound the string. So we designed this guy here, which was just designed to flip down and keep it pinned on the ground until we wanted it to launch. A couple problems with that is it just, when it pushed down, it would kind of lift the robot up. One of these Legos tended to pop off, and so we had to go through and redesign that as well, which we'll talk about here in a moment. So the final touches, final redesigns. Daniel, did you want to talk about the ball loader?
Originally, when we were making the ball loader, we couldn't really figure out what to do. We were going to use a cup system. After some fiddling with the cup system, we found it didn't work. So we hit to a tower system, holding the balls and having them be dispensed all at once, sort of like a Pez pen upside down. And it wasn't very structurally sound at first, but after a few redesigns, we got it to be pretty stable.
And then we already kind of talked about the launcher arm. As far as the device to hold the arm down, we redesigned it into this here. By bracing it on both sides and having just one piece of the arm actually hold onto the hand, it tended to be a lot stronger. We didn't have Legos flying all over the place like previously. Programming this time around was honestly the easiest part. I had a lot more difficulty programming last project with the car. There's a lot of math involved in the programming. This one was pretty much start motor, stop motor, start motor. So as this goes, motor A, which is going to be the motor that pulls the string down for the catapult to load, comes down about 16 rotations until the hand is level with the ground. Motor C is going to be the ball loader, so it'll spin half a rotation, kick out one ball, and once that ball lands in the cup, motor B is going to lock it down. Then motor A fully unwinds, so that way once we are ready to release motor B, all that strength in the rubber bands is just released at once. And then have it repeat 3 times, launch 3 balls. So reflecting back on this next project, what we'd like to do is kind of divide and conquer. We've talked a little bit about divvying up our team into a separate team, so we maybe have 2 or 3 guys doing the designing initially, 2 or 3 guys coming up with some programming, and then switch roles. That way we can just check each other's work and continue to improve. Group meetings, we should probably go with some more group meetings just for better time management. That way if we do run into problems, we're not rushing at the end to kind of get everything figured out. Did anybody have any questions for us?
Okay, yep, thank you. Uh-oh.
Disqualifying.
Just a moment, wait.
Oh.
What?
It's not letting it fully wind up.
Oh
The
shoot.
rotations.
That's not good. It's because the rubber bands are stretching out.
Yeah. Nope, no go.
Okay. Hope it doesn't do that again. Well, it's gonna.
I put this on here. Again, or same thing?
Same thing.
The rubber band's just broke.
That, and we'll see what happens here.
Works fine with the rubber band.
Same thing.
Yeah, well,
Wait.
Yeah, that's what's going on. The rubber band broke.
Oh, now the gears are slipping.
yeah.
Okay, okay.
Too much force for it,
So there's another lesson here.
It works, yes.
Don't over test. Okay. So can you fix that pretty soon now here?
We can.